Okay, so today, continuing on with our Laplace transform playlist, what I want to do is find a value for the Laplace transform of cosine of AT. And instead of going back to the definition of the Laplace transform, in this case, what I'm going to do is use the values we found in the previous two videos. So I recently did the Laplace of sine AT, and we have this value, a over s squared plus a squared. And we have this formula for a derivative. The Laplace of the derivative of some function f of t is s, capital F of s minus f of 0. Okay, now to start with, for my f of t, I'm going to use just this sine AT value. So we're going to set f of t equal to sine AT. And the reason for doing this is because the derivative of sine is just cosine. So if we get our f prime of t value, this is going to be cosine AT, but with the chain rule, we need to bring an a out front here. But because what we're looking to do is we want to find the Laplace of cos AT, let me just isolate cosine AT by dividing by a on both sides. So we can say cosine of AT is going to be f prime of t over a. Now before we go ahead with this, one thing I want to mention in this formula for the derivative, we have this capital F of s. This notation here, it just has the meaning that this is the same thing as the Laplace of f of t. And in this case, our f of t is sine AT. So this capital F of s is going to be the same thing as the Laplace of sine AT. But we actually have that value right here. So this is going to be our f of s value that we're going to use. Now going ahead with this Laplace transform, we actually have this value for cosine AT right here. So we're going to use that and we'll rewrite this. We'll write this like this. So we're going to have f prime of t over a. But now a is just a constant value, and in Laplace transforms, like with integrals, you can always bring a constant out front. So I can rewrite this as 1 over a in front, and this is just going to be our Laplace transform of f prime of t. So now what we need to do is we just need to calculate this thing, but we have our formula right here. The one thing I haven't defined yet is f of 0, but we have our definition of f of t. F of t is sine AT. So f of 0, that's just going to be sine of a times 0, which is just sine of 0, or just 0. So I think we're ready to plug everything in here. We're going to have 1 over a in front. This thing's going to become s. Our f of s value is this right here. So this is going to be a over s squared plus a squared. And then this is just going to be a minus 0 here. But of course, we don't care about that. Then distributing this in here, the a's are going to cancel here. And so we're left with our solution is just going to be s over s squared plus a squared. One quick note on this, we still have this condition that s needs to be greater than 0. This we found in the previous video when we were doing the Laplace of sine AT, and we're using that formula from the previous video where we had this condition that s needs to be greater than 0. So we still need to include this with our answer here as well. Okay, that's it. We'll stop it there. Thanks everyone for watching. Have a good day.